You're welcome to Edumat Hub. So in this topic, in today's video, we'll be dealing with chemical equilibrium for your JAMB Chemistry. So we're covering this topic real quick. So let's start real quick. So the first thing you want to understand about chemical equilibrium, this is a very important topic and JAMB always sets it. So what is chemical equilibrium? First of all, you must know what is equilibrium. Equilibrium has to do with the state of balance. When something is balanced, like the two sides are balanced, then you can say there is equilibrium. Now, chemical equilibrium, or let me just say equilibrium is a state of a system where there are no observable changes in the properties of the system with respect to time. Now, let's assume a reaction like you have A plus B combining to give C plus D. Now, when A and B combines to give C and D, the rate at which this forward reaction, because in this case here, there are two directions this reaction can follow. This reaction can go in the forward direction like this. This side is the forward direction. Then it can also go back like this here. So this one will be called the reverse direction or reverse reaction. While this one will be the forward reaction. So I can write arrow at this point and I can write F at this point. So when I say F, I mean sorry. Okay, Joseph, what's the question? Ask a question, Joseph. So when I say forward reaction, I mean A plus B combining to give C and D. And when I say backward reaction or the reverse reaction, I mean C plus D combining to give A plus B. So when this reaction is taking place, as in the way A plus B is combining to give C plus D, that same rate, C plus D are also combining to give A plus B. Then you see the reaction is in equilibrium. You understand? That means the reaction is balanced. Take for example, let's look at dissolution. Something called dissolution. Dissolution has to be do with like when you're dissolving something. When you dissolve a salt, basically when you dissolve a salt in water. So let's pick an example. This is very important. So pay attention. You cannot do without chemical equilibrium in your JAMB mathematics. So JAMB always set questions on chemical equilibrium. So pay attention. So let's take an example of a salt. Let's use NaCl. NaCl is sodium chloride, Abi. This is sodium chloride. Now, when you dissolve sodium chloride in water, it will go to NaCl aqueous. NaCl aqueous. Joseph, you just have to practice. You need to cover the syllabus first. Sorry. You need to read first before you can do pack. You don't do pack without reading. You must have read something before you can do pack. You understand? Don't just do pack like that without reading. So let's continue. So when you dissolve NaCl in water, please pay attention and ask. So when you dissolve NaCl in water, let's see, NaCl dissolving in water, give you NaCl. You put aqueous at this point. Aqueous because at this point here, the salt is already dissolved in water. Now, in this system, at any given point, the undissolved sodium chloride, this one is solid chloride, are dissolving, while at the same time, the sodium chloride that are dissolved are also precipitating. So you have a forward part and a reverse part as the NaCl salt is being dissolved. The same way, some of the NaCl are precipitating back to form the NaCl solid. So in this forward reaction, you can call the forward reaction, you can say the forward reaction is called dissolution, which is like dissolving, while the reverse direction will be called deposition. Call this one deposition. That's if you're going back. So I will put an arrow here. This arrow is for the forward direction, where this backward arrow is for the reverse direction. Then I'll just write NaCl at this point. Then I'll put NaCl at this other side. I'm going to put aqueous here to tell you that it is in the dissolved form. So when a system like this, the forward and the backward reaction are occurring at the same rate, then you say the system is in equilibrium. You understand? So Joseph, you must read first before you can answer pack. You cannot just answer pack like that. You must have covered it. You must have read some parts from the syllabus. So let's move to the next part. What is a reversible reaction? Now, definition of a reversible reaction. Please be asking questions. Be asking questions if you don't understand. Be asking questions. So let's look at reversible reaction. Reversible reaction. So what is a reversible reaction? So a reversible reaction is a reaction that proceeds in both directions under suitable conditions. So this reaction can proceed in, like I said earlier, forward and backward under suitable conditions, under certain conditions. So you can have something like A plus B combine in the forward direction to give us C plus D. This is forward and this is backward. Let me just use reverse direction. So when I say reverse direction, I mean backward. When I say forward direction, I mean forward, like this. So when A plus B combine to give C plus D, at the same rate, C plus D combine to give A plus B, then you say the reaction is in equilibrium. Okay, I hope you understand that part. There is something called, this one is a product, don't forget, this is product side, this is reactant side. If you understand this thing, there's no way you can miss any question. You cannot fill any question in your JAMB concerning this chemical equilibrium. Just pay attention and follow me as I'm teaching you. If you have any question, just ask me, and I believe that you're going to understand it. So don't worry, just relax your mind and follow me. Okay, now this reaction will be in what is called dynamic equilibrium, when both the forward and the reverse reactions are taking place at the same rate. Forward and reverse taking place at the same rate, then you say the reaction is in dynamic equilibrium, and at that point there is no net change in the concentration of the reactants. Okay, so the reactant is, the concentration of the reactants is constant in the product side and the reactant side. Okay, now let's look at something called a closed system. So what's a closed system? So a closed system. So you have two types of system. You have closed system and you have another one called open system. So what is this closed system? Let's talk about closed system first. So when a reaction please pay attention. When a reaction, like a reversible reaction, like the one I just described earlier, when it reaches dynamic equilibrium in a closed system, like you have a reaction taking place and you covered it, like the reaction taking place in a pot and the pot is covered. You understand? The pot is covered. That is a closed system. Then you have a reaction taking place in a pot and the pot is opened. There's no cover on it. That is an open system. You understand? So let's look at this example. So when a reaction takes place in a closed container or a closed vessel, where during the process of the reaction, all the reacting species, like the reactant and the products, these reacting species that are present, then that is a closed system. The reactants and the products are present at the same time. That is a closed system. But in an open system, which is this one here, in an open system, this is a system in which one or more of the substances are being removed. That means as maybe the products are being formed, the products are escaping. They are escaping from the system. You understand? But only the reactants will remain. This is an open system. One of them is escaping, like performing an experiment in a test tube. Performing an experiment in a test tube, and the test tube is opened, then that means that's an open system, because this system will be exchanging heat to the environment. But if this thing is covered, then you call it a closed system, because it's not able to exchange heat to the environment. You understand? That will be a closed system. You understand? Tea in a closed cup. Thank you. Deep. Thank you. You're correct. Tea in a closed system. So please, that is about closed and open system. We move to the next part, which is, please pay attention. I will now teach you how to write equilibrium constants. The next part is how to write equilibrium constants. This one is very important. How to write equilibrium constants. So we're looking at equilibrium constants for a particular reaction. So let's look at what is this equilibrium constant. So the effect of concentration on the reaction rate was studied by two guys. Those guys were called Goldberg and WAEC. So see their names. Let me give you their names. Goldberg and WAEC. Sorry, just a minute, please. So these two guys here, one of them, his name is WAEC, and another guy called Goldberg. These two guys, they studied effect of concentration on different reactions, and they came up with a law called the law of mass action. The law of mass action. So what does this law state? I'm going to give you the full breakdown now. So this law states that at constant temperature, listen carefully, at constant temperature, the rate of a reaction is proportional to the active masses of each of the reactants. Take note, this is the law of mass action, and it will help you to understand what is the equilibrium constant. And let me teach you how to write the equilibrium constant for a particular reaction. Now look at this reaction now. Look at this reaction. You have A plus B combining to give C plus D. And this A here, the number of moles of this A, let me just say it is Y. Number of atoms of this B, let me say it is P. Number of moles of C, let me say it is A. Number of moles of D, let me say it is B. So let me just write it as YA plus BB produces AC plus BD. So how will you write the equilibrium constant, which is called KP? Okay, if anybody knows it, you can put it in the comment section. Ask a question, Franklin. Just ask. Don't say you want to ask. Just ask the question. I'm here for you. Don't take permission to ask questions. You understand? Don't take permission to ask. Just ask your question. Ask a question. Ask a question. So if anybody knows how to write the equilibrium constant, you can just proceed with me. So let me teach you how to write it. So to write this stuff, you have to look at the product side first. Start from the product side, then divide by the reactant side. Okay, start from the product side and divide by the reactant side. And JAMB, not to confuse you, JAMB will give some options that have reactant side over product side. So you have to be very careful because it can be very tricky. So look how to write it here. So first of all, you start with the product side. So you write C. This C here, put this in square bracket like this. Then A, this A will be a power here. The next one is D. Then this B will be a power here over. The next one is A. Then Y at the top. Then B. Then P. Then put it like this. Don't write plus in the middle. Please don't write plus in the middle. Don't write plus. The middle should just be left blank like that. But it means that it is times that is there. So this stuff here is called the equilibrium constant. You understand? So all you have to do is just take the element, take the products and put their coefficients as powers. Put their coefficient as powers and divide it by the reactant side. Do something for the reactant side, and that will be the KP. So this stuff is called the equilibrium constant expression. Any question? Any question? Any question? Any question? So I'll move to the Chattelier's principle now. The Chattelier's principle, and we'll continue from there. Any question before I move on? But yeah, anyone that wants to try, you can try this one now. Tell me the equilibrium constant of this reaction. AX plus BY equals to CZ. Yeah, try this one if you know the answer. Write the equilibrium constant expression. Yeah, try it. Try it if you know the answer. Give it a try. Okay, you don't understand. Okay, which part don't you understand? Just mention the part. Don't say you don't understand. Which side don't you understand? Like, let me know where you don't understand. It's like most students are not online right now. Write the equilibrium constant expression. Yes, JAMB will ask this in question. Okay, let me do it again. Watch the way I'm doing it. Watch the way I'm doing it. Let me take an example. Sorry, then watch the example. If you want to write the equilibrium constant expression, watch the example. I'm using P, or let me say, yes, PC plus QB produces MA plus NB. So I want to write the equilibrium constant expression. Take note, you will start from the product side. This is the product side you will write first. These are the numbers. These are the number of moles of the products. For example, this one is PC plus QB equals MA plus NB. So you just write K. This is how you write it, K. Then go to the product side. Write the two products there, AB. A. Put it in square bracket like this. Tell you that you are dealing with the concentration. Put this M as a power here. Go to B. Cover it. Put this N as a power over. Then go to the reactant side. The reactant must be under. Put the P there. Don't put anything in their middle. Don't write minus here. Nothing will be in their middle. So it is times that is there, but don't write the times, but it is assumed to be times. So this is how to write it. I hope you understand now. So let's assume you have a reaction like this now. See, you have something like maybe H2. Let's do an example. Plus O2 produces 2H2O. Let me put 2 here. The next you should write the equilibrium constant reaction. So equilibrium constant expression rather. So I'll start with the K from this side here. Product side, this place must be at the top, or here must be at the top. So I'll write H2O. I'll cover it like this. Who can tell me what I'll write here now? Let me see who is following. Who can tell me what I will write here? What will I write at this place? Who can tell me what I will write here? Oh yeah. 2. That's correct. I'll write 2 here over this one, O2. I'll write 1 here, or just ignore it. Then this one here, I'll write H2. Then I'll put 2 here. So this is the answer. So you can see it's easy to write. It's easy to write. Okay, so that's how to do the equilibrium constant expression. Now, can I move on? Let's now go to what is called the Chatellier's principle. The Chatellier's principle. Students always confuse this. Students always confuse it, but they always mix it up. But it's very simple. The Chatellier's principle. Now let me teach you one scope. This scope, you get the answer no matter where they're going to bring the question from. No matter the JAMB question, you will get the answer. Now let me tell you what this principle states. Let's look at what it states first. So one particular guy, they call the guy the Chatelier, and the guy named that. So the guy named come up with this law. The guy does say it states that if you check the textbook, you can see the definition there. We'll look at what's given for pigeon. He said if an external constraint or an external stress is applied to a system, or a system that's in equilibrium is caused to change, or the constraint is caused to change, then that stress imposed on the system, which is in equilibrium, will cause another force that will counteract the initial stress on that particular system. So there are different definitions of it, but that is a simple way. You can also say if the external constraint, so if an external constraint, such as a change in temperature, pressure, concentration, those 3 things, so don't go and do over Sabio, those 3 things is imposed on a chemical system in equilibrium. The equilibrium will shift in such a way that so as to annul or counteract or neutralize the change. Listen carefully. It's very, very simple. There are 3 things that this Chatelier principle talk on. The first one is concentration. The next one is pressure. And the last one is temperature. Any of these three things, if it causes a change to a system that's already equilibrium, the system will change itself and counteract that particular change. You understand? Take for example, you remember from Lenz's law, like you have a coil. Let me go to physics more. You have a coil like this now. This is a coil here. You now put a magnet. You connect this coil to a galvanometer like this. You now put a magnet here. You now bring a magnet to this coil. If you are coming with the north pole of the magnet, you are moving this magnet, the north pole of this magnet, you are bringing it towards this coil that is stationary. This is one that is moving. So you are moving this coil like this. You are moving this magnet rather like this. And this side is the north of the magnet. So because you are moving this north to come and meet this guy, this one here, the way the current will flow on this coil, it will be in such a way that it has to oppose this knot. That means this place will turn to knot 2. It has to prevent you from coming, like you are coming. It will prevent you from coming. That means to send you back. And remember that knot will repel. Knot will repel. Why south will also repel. But north and south will come towards each other. They will attract. So that means that if you are bringing the north pole towards this coil, because you are coming, it wants to push you back, like come on, go back. It wants to prevent you from coming. So this coil will change to knot 2. This coil will change to knot to prevent you from coming, to send you backward, to prevent you from coming. That's just what it's talking about there. So the way the current will flow here, it will be in such a way that this place will be knot. But what if it's the opposite way? What if you are going? You understand? You are going with knots. You are moving away like this. It will want to bring you back. That means it will want to turn to south pole, so as to bring you back. You understand? So if you are coming, it will want to send you back. If you are going, it will want to bring you back. It's the same thing here. We are talking about the Chattelier's principle. So in the Chattelier's principle, we are talking about 3 things. We're talking about 3 things: concentration, pressure, and temperature. So let's look at the first one now. Effect of change in temperature. So let's look at this reaction. We're looking at change in temperature now. Change in temperature, effect of change. This thing is very simple. Just follow the way I tell you. You go get them. You know if you miss them. If you follow the way I teach you like this, you know if you miss them. See, A plus B give you C. They will now put something like delta H here. They write delta H. This delta H here stands for the enthalpy. That means the heat that has been lost. You know, some reactions can take place that everywhere will become hot. Imagine a reaction like imagine you are turning a bar now. You are making a bar. So if you are turning the bar, the environment will be hot now. That's an exothermic reaction. So delta H there, delta H, the heat change there is negative. Why? Because if that reaction takes place, everywhere will be hot. Imagine a reaction that takes place and everywhere is hot, like you are burning firewood. Everywhere will be hot now. And I can. So that kind of reaction is called an exothermic reaction. So that kind of reaction, this delta H rather will be negative. It will be negative because the environment is hot. But look at this other one. C plus D produce let me say E, and delta H is positive. Oscar, Jonathan, Alpha, welcome. So this delta H is positive. That means this reaction, if it takes place, it will take heat from the surrounding. Everywhere will become cool. That's the meaning of this one. If this one take place, everywhere will be hot. This one is exothermic. You call this one exothermic. Who can tell me what the name of this one? Who can tell me the name of this reaction that delta H is positive? Who can tell me the name? Like the live. Let's go. Like the live. What's the name of this reaction that makes nice one? This one is endothermic. So if you have this kind of reaction, let's look at the first one. Thank you. And they can go here. Do I get it? I see you. Jessica, thank you. So let's look at the first one. A plus B gives you a negative reaction. That means it's exothermic. So what will happen if you increase the temperature? If temperature is increased, what will happen to this reaction? If temperature is increased, or if temperature is decreased, what will happen to it? It's very simple. Look at the way I'm going to give you now. So watch you. So let me do the first one. Let me do endothermic first. Endothermic reaction. Endothermic. So I have A plus B produce C, and they will put delta H here. You will see delta H is negative. Listen carefully. Do not tell you that what happens if temperature is increased. What happens if temperature is increased? Now look how to get it. It's very simple. Now to get this thing, what will happen if temperature is increased? This reaction is endothermic. That means it needs heat to occur. That means you need to put in heat. You need to put heat. If you don't put heat, this reaction cannot move to the product. This is the product here. You understand? This reaction cannot occur if you don't put heat. Imagine you want to make semo. I say semo, yes, semo or custard. So you first of all warm the water now. The water must be hot. If You now pour the hot water on top of the semo. That's the same thing here. That reaction is endothermic because it needs heat to occur. But later, everything will not be hot later. So because it needs heat to occur, if you now increase the heat of the surrounding, like you put in more heat, this reaction needs heat. You now put in more heat, what will happen? That means it will favor the forward direction. So if you increase the temperature of let me make this one to be endothermic. Sorry, I made a mistake here. This is endothermic, not exothermic. So what this reaction is endothermic. If I put in heat into the system, endothermic reaction needs heat. You must put in heat for it to work. So then I said I should put in more heat. Because the heat I'm putting is too much, I'm disturbing the system. It's already in equilibrium. I'm not disturbing, I'm putting more heat. What will the system do? The system will try to reduce the heat from the reactant side. Because the heat here is too much, I'm adding more heat. It will try to reduce it. And how will it reduce it? It will use the heat to produce C. That means more of the product will be formed. That means more of C will be formed. Or you can say the reaction will favor the forward direction. Or you can also say the equilibrium constant will move towards the right. Or you can say the equilibrium position will shift to the right. Okay, let me say it again. Please let me say it again. Follow up. Let me say it again. You see this reaction here? This reaction is an endothermic reaction. Endothermic because it needs heat. This reaction, it needs heat to occur. As in, for it to start, you must put something hot into it. So because this reaction is endothermic, they now say what will happen if I put in heat? Like what will happen if I add heat to this reaction? That means since this reaction needs heat to occur, and I put in heat, what will happen? That means it will go forward now. It will favor the forward direction. That means I'm adding heat on this on the left hand side. So the reaction will be like, this heat is too much. What will I do with this heat? It will now use the heat to combine A plus B to form C. That means more of the product will be formed. That means the equilibrium position will shift to the right. You can say it like that. Or you can say the forward reaction will be favored. Or you can say more products will be formed. You understand? Or you can say the equilibrium position will shift. Anyone you want to, everything are the same thing. You can say the equilibrium position will shift to the right. The forward reaction is favored. Anywhere you want to put it, all of them are correct. So I hope you understand. Do I get it? Hope you understand. Now, what if the temperature is lowered? What if the temperature is lowered? You now reduce temperature. What ought to happen? You are lowering temperature instead of increasing temperature. So see how it is here. You have A plus B give you C, and this reaction is endothermic. They now say the temperature is reduced. Temperature is reduced. That means the temperature is dropping. So what will happen? You know that this reaction, endothermic, it needs heat. It needs heat on this side to boost forward. For it to go forward like this, for it to go like this, you need to put heat here. That means you need to put heat. But because you are reducing the heat, it will be shocked now. Why are you reducing my heat? I need the heat and you're reducing it. So it will favor the backward reaction. Thank you. It will favor the backward reaction. So you can say the backward reaction is favored. Or you can say equilibrium position shift to the left. Or you can say more reactants are formed. Anyone you want to use, all of them are correct. You can also say the reverse direction is favored. Anyone you want to use, all of them are correct. So I hope you understand. That is about endothermic reaction and temperature. Now let's look at exothermic reaction. Any question on endothermic and temperature? Let's go. Any question on endothermic and temperature? Check fast. Endothermic and temperature. Any question? If I go to exothermic. Okay, do I get it? What's the question? Ask a question. Or should I ask you guys a question? Okay, let me ask a question. Look at this JAMB question. This JAMB question says, given the reaction N2 gas, nitrogen gas, plus oxygen gas at equilibrium, then it gives you 2NO, which is nitrogen 2 oxide, and delta H is positive 90 kilojoule per mole. This is per mole. Don't mind, this book is too small. Per mole. So they now ask, it's endothermic or endothermic. So the question is, what will happen what will happen if the temperature is increased? Yeah, try this one and tell me the answer. What will be formed, or which side will be favored if temperature is increased? Yeah, try it. Try this one. You know, in JAMB Chemistry, you learn by practicing. When you practice, you learn. You're allowed to make a mistake. You can make mistake. It's normal to make mistake. You can make mistake. It's normal. But the more questions you do, the more you learn. Yeah, try this one. What will happen if the temperature is increased? Okay, forward reaction will be favored. That's Biola Aishat. That's perfect. Nice one, Biola. Biobaku. Sorry. More 2NO will be formed. Nice one. Forward reaction is favored. Nice one. NECO and Dofia. Tonye. Nice one. So all of you are correct. That means that all of you are following. That's good. Good job, guys. This NO here, in case you want to call the name, this nitrogen 2 oxide. Nitrogen 2 oxide. Okay, so let's go to exothermic now. I think we're okay with this one. Now, exothermic now. For exothermic, so this reaction gives heat to the surrounding, and delta H is always negative. It's negative. So look at this example. C plus D combine to give, let me say F, and delta H is negative. But please, before I proceed with this thing, hold on, I want to show you something. Pay attention, I want to show you something. Some students might not understand it, but let me just show you. Look at this reaction. Sorry. Look at this reaction here. A plus B produce C, and delta H is negative. Please pay attention. This thing will change. It will change your. Yes. Attention. Moving to concentration. You are correct. But look at this thing first to understand it better. A plus B produce C. Delta H is negative. If you reverse this direction, this thing. If you reverse this reaction, take note to delta H is negative. But I want to reverse it now. I want to put this C on this in this place and put this A plus B here. That means I'm writing it like this. C give you A plus B. Because I have reversed it, this delta H now will be positive. Take note. To be positive. Please, this is very important. If you understand, it's very, very important. This is what you'll be given. A plus B produce C, delta H negative. But if I reverse it, if I put this C here and put this A plus B here, this whole thing will become positive. This one will be endothermic. Just like this reaction now, you can see it is endothermic at this point here. N2 plus O2 give you this one. But if I reverse it, if I write this 2NO here, like this, 2NO produce N2 plus O2. This one now, because the initial one was positive, now it's going to be exothermic. I'm going to write delta H negative. Please, this thing is very important. When you reverse the reaction, the delta H will change. Okay, I hope you understand that one. Now let's go to exothermic now. Now for this exothermic, take note of exothermic. If it takes place, everywhere will be hot. An example of exothermic reaction is if you are cooking in your kitchen, everywhere will become hot. They are cooking for, maybe they are making like party, they are cooking rice with firewood, everywhere will be hot. So that's combustion reaction. When something is burning, the environment will be hot. Now this reaction here, this exothermic reaction, when it takes place, the environment will be hot. That means the environment should not be hot before. If you want to enjoy this kind of reaction, if you want it to take place very well, don't make the environment too hot before you start this reaction. Let the environment be calm. then start the reaction. The reaction will proceed very well. So that means that for this exothermic reaction, if you increase temperature, they say what will happen? What happens if temperature is reduced? What will happen if temperature is reduced? This reaction normally, it likes to make everywhere hot. When it's taking place, everywhere become hot. Now, something says it likes to make everywhere hot. You're now reducing the temperature. I want to be in a hot place. I like it hot. You are telling me that I cannot be in a hot place. What will I do? I will ginger myself up now and try to make everywhere hot. That's the same thing that's going to happen here. And how will this reaction make itself to be hot or make the environment hot? That means it must go forward. So if the temperature is lowered or reduced, it will go forward like this. This is the forward direction. So exothermic reaction, if you lower the temperature, it will go forward. Or you can say the equilibrium position will move to the right. Or you can say more products will be formed, as in C plus Z produce F. More of F will be formed. The reaction will proceed forward. But if you increase temperature, if you increase the temperature, what will happen? It will go back. And listen carefully. Let me tell you why it's even like that. It's even easy. Since the forward is exothermic, the backward will be endo now. The forward is exo. The back will be endo. If I reduce temperature, it will go forward. If I increase temperature, remember from what we did before. If you increase temperature of endothermic, it will go forward. So that means that if you increase temperature of exothermic, it will go backward. And backward is where? Backward is favoring endothermic. Hope you understand. So if the temperature of an exothermic reaction is reduced or it is lowered, it will favor the forward reaction. And if the temperature of an exothermic reaction is increased, it favors the backward direction, or equilibrium position will shift to the left. Anyone you want to use? Any question? Before we move to concentration. Any question? Check. What's the question? Biobaku. Check. The next user. Okay, no more question. So before we move on, JAMB from the JAMB syllabus, they said we should look at an example using NO2. We should use NO2 and the N2O4. So let's look at that example so that we'll not skip anything from the syllabus. So we're going to be looking at this equilibrium reaction, N2O4 produces 2NO2. Okay, now let's look at this reaction. So please pay attention. Please, a minute, hold on. All right, now this stuff is very, very important. Listen carefully. This N2O4 is a dimer. Let me just put it like that. It's a dimer. Okay, it's a dimer. So the name is dinitrogen 4 oxide. That's this N2O4. This one is nitrogen 4 oxide. So this stuff here from the syllabus, JAMB says you should check this, like you should know the effect of this N2O4 to N2. Now you must also know their color changes. Take note of the color changes of this N2O4 and NO2. I'm going to give you the color changes now. So for NO2, which is nitrogen 4 oxide, the color is reddish brown. This one's color is reddish brown. That's the color. It's a reddish brown gas. While this N2O4, the color is pale yellow. This one is pale yellow. And this reaction will proceed in the forward direction when there is heat. So heat will make it go like this. And when you cool it down, when you cool your system down, this one is cooled. When you cool it, it will go back like this. when you increase the heat, it will go forward. So this reaction is endothermic like this. The way it is like this is endothermic. So it's endothermic like this. So if you increase the heat now on this right hand side, it will proceed and form 2NO2 gas. That means this pale yellow color of this N2O4 gas will reduce and you start seeing reddish brown color. Please like the live. Let me to like the live, guys. Thank you. Let me to like the live. So you start seeing pale color of this red 2NO2. But if you now allow it to cool, it will now form your pale yellow color back. Please hope you can understand the difference. And if you are new here, please make sure you subscribe. Now let's go to concentration now. Concentration. Before we go to effect of pressure. Now for concentration, please pay attention. This concentration, students normally get confused too. Now, effects of change in concentration. Effects of change in. So I'm going to use the same format. A plus B produce C. And I'm going to use the one that is double. A plus B produce C plus D. So let me start with the first side. So if you look at the first case, A plus B produce C. What will happen if the concentration of A is increased? Good question. Very perfect question. JAMB has asked this before. So let's look at the first case. This one, concentration of A goes up. That means it's increased. This reaction is taking place normally. You now increase the concentration of A. That means you made A to be much. That means the system was already in equilibrium. You now added much or plenty amount of A. What will happen? The system will be like, oh, why are you disturbing me now? It has seen that, oh, this A is too much. What will I do with this A? It will not start reacting the A with the B to reduce the A back to how it was before. It has to use up the A. So it uses up the A and give you C. That means if you increase concentration of A, the reaction will proceed in the forward direction. That means it will go forward like this. If the concentration of A is increased. The same thing with B. If you increase concentration of B, the reaction will be like, oh, why is B increasing? What will it do? It will not start reacting the B, the excess B you're adding. Please remember to subscribe if you're new here. Thank you. It will not start reacting the B with the A. And when it's doing that, it will be forming C. So if concentration of A is increased, that means A is too much. What will it do? It will use the A and combine with B to form C. That means it will go forward. You understand? So if you increase one part, it will use it up and use to proceed the other side. Let's look at if A is increased. You have done that one. What if A is reduced? If you are reducing A, it will be like, A is going down. A is going down. What can I do to make A to go up? It will now favor the backward. It favor the reverse direction so that it will produce more A. C will start breaking down to form A and B. You understand? So if A is lowered, the reaction will go backward to produce the A because A has gone too low. It's A is too low. What can I do? It start producing A. That means to go backward. You understand? Let's look at this one now, for example. This one now, what if I reduce D? Concentration of D goes down. It will be like, this thing's already in equilibrium, and D has gone down. What can I do? I need to produce more of D. To produce more of D, how will it go? It has to go forward. You understand? It has to go forward like this. That means if D is reduced, it will favor the forward direction. Favor the forward direction like that. Bah. And the same thing, if C is reduced, you favor the forward. But what if this C is increased? Like this C now is now increased. It will be like, C is too much. Oh, C is too much. C is too much. What can I do? It will not start favoring backward. It will be using up the C. You start combining the C and the D to produce A and B. To be going backward. Please, hope you understand the way I explained it. Ask questions. Ask questions. Ask questions. This topic is a very important topic. So ask questions if you don't understand. Do you understand the way I said it? Question time. Okay, ask a question. Okay, let me ask a question. Let me confirm that you understand it. What if B is reduced? Yeah, which direction will be favored? If B, you don't understand concentration. Okay. Concentration is about increasing one part. Like if it is high on one part, then you have to lower it on the other side. Like for example, listen carefully. This reaction is A plus B produce C plus D. If this B is reduced, that means that A cannot combine with plenty amount of B again. Since you are reducing the B, this system will be like, this B is going down. What will it do? It has to produce more B. And how will it produce more B? That means it must favor the backward direction now. It must favor the backward to go to where B is. This thing is very, very straightforward. Don't let it confuse you. Okay, let me ask a question now. What if C is increased? If C is increased, that means C is going up, Abby. It will be like C is getting too much. Let me reduce the C. And how can you reduce the C? To favor the backward direction. It has to use this extra C you are adding to combine with the D to get A and B so that the C will be reducing. You understand? So it's just about increasing one. If it's increasing one part, it will drop on the other side. That's about this concentration thing. If it increases in this side, it will drop here. If B is high here, then this reaction will go forward. And if A is high, let's assume A has gone high. It will be like, A is too high. How can you reduce A? It has to use the extra A you are adding to combine with B to get C and D. That means if A is high, it will go forward. And if A is low, it will go backward to favor the production of A. That's just the trick behind it. There's no other trick. Then question. Yeah, 6 example now. Try these questions for me. Try this question. Look at this question. So you have CO gas plus O2 gas produce 2CO2 gas. Yeah, answer this question. Which direction will be favored if the concentration of oxygen is reduced? Answer the question. Please subscribe to the channel. If concentration of oxygen is reduced. Yeah, see the question. Hope you can see it. Yeah, answer the question. Answer it. Which direction will equilibrium shift to if concentration of O2 is reduced? Nope. Some of you are missing it. What I'm saying is this guy is getting low. This guy is becoming low. So where will it shift to? Is it like this or like this? Is it left or right? Somebody has missed it. Check where. Let's move on. No, there's no B here. Gideon, there's no B here. What is here is CO2, 2CO2. Thank you. It will favor the backward reaction. Backward will be favored because this guy is going down now. This guy is going down. It has reduced. Oxygen is going down. Because oxygen is going down, it will be like, oxygen is reducing. What can I do? It has to produce oxygen. That means it will go backward or left. Thank you. It will go backward or left. Another question. What if CO is increased? Where will it go to? Which direction will it shift to? CO is increased. Yeah, concentration of CO is increased, where will it shift to? Is it like this or like this? Forget about this one. There's nothing here now. Focus on the CO. Concentration of CO is increased. Where will this reaction move to? Is it forward or backward? Okay, thank you, Festus. Nice one, Festus. So it will move to the forward. Yes, Biobaku, you are correct. To go forward, shift to the right. Nice one. It should shift to the right. And NECO, you are correct. Gochi, you are correct. It will go to the right. Hope you understand that one. Yeah, let's go to effect of pressure now. Effect of pressure. I think all of you understand that one. Yeah, effect of pressure. Please, if you are new here, follow me. Click on follow button, please. Thank you for supporting me. Effect of pressure. And let me know any topic. David, no vex. No vex, I beg, David. Sorry, no vex. Let's keep my mind. Devo, Asapa, I see you. I dare with you, boss. Now, effect of pressure. Pressure tiwa, like Yoruba will say. Pressure don't too much. This pressure, it is simple like mad. Nice simple. Out of all of them, this pressure, nice simple pass. And if you like you, AJ, that's pressure, nice simple pass. Let's look at an example. So this pressure now, okay, just call the part of organic chemistry where you know now. Just let me know the part, which chapter, which topic of organic chemistry. You understand? We are in organic chemistry. So let's finish on pressure. This pressure is simple die. So hold on, I'm coming on. Let me look for an example. Now, change in pressure now. For a change in, let me give an example. Let me use something like, okay, let me use ammonia, formation of ammonia. N2 plus what? Ammonia now, 3H2. That will give you what? 2NH3. This is ammonia. This is Haber process, like you all know. I'm going to put gas here because this pressure, effect of pressure is only for gases, so it does not affect systems that are solids. It's only for gaseous reactant and gaseous products. This effect of pressure, only for gaseous reactant and gaseous products. Now, pay attention. For a change in pressure to affect the chemical like system in equilibrium, this system is in equilibrium. Sorry, I didn't put two arrows forward and backward. You must consider the reactant. The first case scenario here is for it to have change in pressure, this reactant must be gases. You understand? Gaseous molecules. You must have gaseous molecules, and the reactants and the products must be gaseous. You understand? They must be gaseous. Pressure cannot have effect when they are solid reactant or solid product. Only for gases. That's what I mean. Gases like this. And total number of moles of gaseous molecules on the left-hand side must be different from total number of moles on the right-hand side. That means that if you count the number of moles, this one is 1 here, imaginary 1 is here. If you add it to this next one, this one is 3. So total is 4 now. So on this left-hand side, you have 4 moles. Abina, 4 moles on the left-hand side because imaginary 1 is the fault of this nitrogen. So 1 plus 3, that will give you 4. But on this right-hand side, you have 2 moles. So in this case now, pressure can affect this system. Why? The number of moles on each side is not the same. So that means pressure can affect it. But assuming they are the same, pressure cannot affect it too. If the number of moles on both sides are the same, pressure cannot affect it. But if they are different, pressure can affect it. Please take note of that. I'm going to give you one example like that later. So let's look at what happens here. How can pressure affect the system? Let's look at increase in pressure. Increase in pressure. What will happen if the pressure of this system is increased? Good question. Now, if according to the Chatelier principle, should I'm increasing the pressure, Abi? I'm increasing the pressure. What will the system do? Try to reduce the pressure now. Since I'm increasing the pressure, the system will try to reduce it back. So if a high pressure is applied to a system that is already in equilibrium, the reaction will favor, as in the equilibrium will shift to a position where the pressure will be reduced. Take note, let me say it again. If a high pressure is applied to a system in equilibrium, the reaction which favors a reduction in pressure will be favored. So since I'm increasing the pressure, now look at the sides here. This one is 4 moles, this one is 2 moles. Increase in pressure will favor the side that has the lower number of moles. You understand? The pressure is already high. In a container, when you put gas in the container, if number of moles are high, then the pressure will be high now. But if the number of moles are low, pressure will be low. Imagine you put 30 students inside a small room, and there's ventilation there, there's fan. Sorry, there's no fan, but there are windows there. You notice that everybody will still be relaxed. Everybody will still be okay. But in this small room, go and put 200 students there. That's when you start perceiving body odor. You start perceiving armpits. You start perceiving dirty boxers, and people never bath for 10 days. You start perceiving body odors and different kind of things because they are in a tight room, they are in a tight corner. You understand? They are in a tight corner. Does not make sense now. 200 students in one place. You perceive body odor, different kind of things like you perceive sweat and everything because they are in a tight corner. But put those 200 students now in a big field. Everybody go with ventilation, no problem. So because you are increasing the pressure, you are forcing them to be in a tight corner. What would they do? If I force you to tight corner, what you go do? Maybe go escape to where space there now. So because I'm increasing the pressure, I'm forcing the system to be in a tight corner. This system equilibrium will now change itself and move to favor the direction that have lower number of moles. So increase in pressure in a gaseous equation like this, we favor the side that has the lower number of moles. 2 moles will be favored. Hope you understand. But what if I lower the pressure? Where will it favor? It will favor the side. It will favor the side with higher number of moles. Take note. Favor the thank you, more moles. Blessing, you're correct. More moles. Do I get it? Thank you. Morning. More moles. So this system now, let me check this system. This is 4 moles here. If I increase the pressure, where will it favor? Lower number of moles. It will favor the 4 direction. What if I increase the pressure? If I increase the pressure, it will favor the lower number of moles. That's 2. But if I lower the pressure, it will favor the side that has plenty moles. This place has 4 moles. It's going to favor here. More moles. Thank you. Yeah, do this one. Tell me the answer of this one. Classwork. Tell me the answer of this one. Look at this one. You have N2O4 2NO2 gas. Before we start, let me ask a question. What's the number of moles here? Let me ask a question. What's the number of moles? Oh yeah, tell me the answer first. Tell me the answer of only that one. How many moles there for this left hand side? Try them. How many moles are on this left hand side? Like the live, please. Like the live. Please, if you are new here, subscribe to my channel. 1, that's correct. 1. So this place is 1 mole. Please let me like the live. Support me, please. This place is 1 mole. Yeah, how many moles there for here? 2 moles. Correct. 2 moles. Yeah. Increase in pressure. What will it favor now? Yeah, tell me. If I increase the pressure of this system, which side will it favor? Is it here or here? Increase in pressure. What will it favor now? Is it here or here? Which side? Forward or backward? Increase in pressure. What will it favor? Nice one. Backward reaction. Correct. All of you are correct. That's wonderful. Now, increase in pressure. What will it favor? Increase in pressure. What will it favor now? Increase in pressure. What will it favor now? You are mixing it up. Increase in pressure, where will it favor? Okay, yes, I think no, please check well. You are confusing it. This system, increase in pressure. Backward. The favor the side that has small number of moles now. Yeah, next one. Decrease in pressure now. Decrease in pressure, what will it favor? Where will decrease favor? Decrease in pressure, what will it favor now? Decrease in pressure, what will it favor? Nice one. 2NO2. Nice one. Washere. Agbayi. You are correct. So I think that's about the Chatler's principle. So any question? I hope you understand the Chatler now. I hope you are okay with the Chatler. You have known concentration, pressure, and temperature. And JAMB always said this thing. You always said it, so you have to know how to. All right. Give me your next topic. Give me your next topic. Give me your next topic. Yeah. Give me your next topic. Should we revise organic chemistry? Which part of organic chemistry? Someone said saponification. Okay, NECO. Okay, Princess Ada, Festus rather. That's metal and non-metals. That will be maybe tomorrow. But for now, let's quickly cover saponification. All of us are going to gain. Don't worry. We will gain. We will gain something. So someone said we should do. How about naming? Hope you can name. Can you name organic compounds? IUPAC nomenclature. Can you name? Or if you don't know how to name, talk. Can you name organic compounds? Okay, you can name. Yeah, let's saponification then. Okay, Biwaku said not really. Okay, let me shoot naming for you guys. Yeah, let's do naming. Let's do IUPAC nomenclature because no one knows you must see question on it. IUPAC nomenclature. How to name. So pay attention. The first thing we're going to look at is alkanes. So alkanes, these alkanes, they have what? They have single bonds. Single bonds. What about alkenes? How many bonds? Alkenes have how many bonds? Alkenes. Tell me the bonds in alkenes. Don't worry, I go teach you benzene. Don't worry, benzene is small thing. How many bonds are in alkenes? Double. Actually, nice one. Nice one, blessing. Then alkynes. Alkynes have triple bond. Like this. So if you are naming alkanes, the ending of their name must be ANE. If you are naming alkanes, the ending of their name must be ENE. And if you're naming alkynes, the ending of their name must be YNE. You understand? So let me just give you the general formula for alkanes. For alkanes, I think you all know it before, but this is just a revision before we go to the cocoa. Alkane is just CnH2n plus 2. So what if I put N as 4? What will I get? It will be C4. 4 times 2 is what? 2 times 4. That's 8 now. 8 plus 2. That will give you 10. So C4H10. So this one, what's the name of this compound? What's the name? Tell me the name. Tell me the name fast. Tell me the name. What's the name of this guy? Let's go. The fourth member, butane. Wagbayi. So this is butane. Now this butane, that's 4. That's what I'm trying to do. Do I get it? That's what I'm trying to do. So this is butane.
Now this butane here is the first member, is the first alkane member. JAMB asked last year that has isomer, that has an isomer. So what are isomers? Isomers are just two compounds that have the same structure. Sorry, that have the same molecular formula. Two of them have this formula, but they have different structure. They don't look alike, but they have the same molecular formula. Imagine two people that have the same name. They have the same name, but they don't look alike. That's isomer. So the first alkane that has an isomer is butane. Now, what if you want to draw the isomer of butane? How will you draw the isomer of butane? So see how to draw the isomer of butane. First of all, draw butane normally. So this is butane here. Butane is C4H10, abi? That means you will draw 4 carbon first, like this. Then on each of these lines, you will now put hydrogen, like this. You put hydrogen like this. Have you seen it? Please, if you are new here, make sure you follow me, please, and subscribe to my channel. This is butane. Now I want to get an isomer. Isomer means I want to get another compound that looks like this one, but it has the same, like this same formula, but it does not look like this. So see how to do it. This stuff is very important. So learn how to do it. You can even do it with your hand. So see how to do it. The first thing to do is, since it has 4 carbon, remove 1 carbon from it. Remove 1 carbon. How many carbon will now be there now? Yeah, how many carbon will be there if I remove 1 carbon? How many carbon will now remain? I'm trying to remove 1 carbon from there. So it will remain 3. So that 3 carbon, I'll now arrange it straight like this. Arrange it straight like this. So this is now 3. See the way it is. Now this one that you remove now. So this is the part that you remove now. This is where you removed. This part that you remove. Don't attach to the ending here. Don't let it be at this ending. Let it be in another place. So this is like carbon 1, carbon 2, carbon 3. Don't put this carbon that you remove. Don't put it on carbon 1 or 3. Don't put it at the last place. Put it in another place. So who can tell me where it will be now? Who can tell me where I can hook this carbon to? Where can I hook this guy to in this structure? Where can I hook this one to? Yeah. It must not be in the first. It must not be in the last. Up. Thank you. That means it must be on 2. You can be on 2 like this. You now put it here. Then put your normal hydrogen for all of them. Put your hydrogen. Hope you saw the way I did it. So what will now be the name? Let me put the hydrogen now. So if you want to get the name of this guy now, watch how I'm going to get the name of. Look for the longest carbon chain. That means look for the longest road, the longest straight road like this that I will see. So this is my road here. This is my road now, straight road. This is the longest road. Any road that is not on this road, that is not on, so this is my road here now. This is my road. Any road that is not on this, any carbon that is not on this road is a branch. You call it branch. You call it branch. Subscribe to my channel. Subscribe to my channel. So this guy here, sorry. This guy here is my road. Like this is my road. This one is not on my road. That means this one is a branch. This guy is a branch. So how many carbon atoms are here? 3. If it is 3, you call it prop. So that will be propane. And the branch is on the middle carbon. That will be 2. So the name is 2-methyl propane. It has the same formula as C4H10. Why? How many carbon are there? 1, 2, 3, 4. Abi 1, 2, 3, 4. 1, 2, 3, 4. That will be C4. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. You can see. 2-methylpropane has the same formula. That's the same formula. While normal butane too has this formula. So this guy is an isomer of this guy. Do you understand how I got it? Let's try another one. Let's try for pentane. Isomers of pentane. Let's see if we can get the answer. Pentane. Yeah, tell me the formula of pentane first. Pentane. Tell me the formula of pentane. Let's go. Formula of pentane. Let's get the isomers of pentane. Yeah, isomers of pentane. What's the formula of pentane? Ugochi, the branch cannot have the longest chain. If the branch has the longest chain, that means you have to go and count on the branch. Count the longest chain on the branch. Don't worry, I'll teach you that type. Okay, I'll teach you that type. Don't worry, Ugochi. So C5H12 is the formula for pentane. So this is my normal formula. C5H12. What will I do? Five carbon, Abi. Let's go. 5 carbon. Let's go. 1, 2, 3, 4, 5. Abi now. The next thing, hydrogen, Abi. Hydrogen. Abi now. Abi. So what's next? Put your hydrogen on all of them. Then what will be the next step? I want to get the isomer. The first step, remove 1 carbon. Oh yeah, let's go. Let's remove 1 carbon. Let's remove this guy. This is normal pentane. Oh. Normal pentane. So this one is called N-pentane. That means normal pentane. The normal structure. The straight chain. No branches. The road here is straight. See, straight road. No branch. No branch. Everybody there on straight line. Now I'll remove 1 carbon. I'll remove 1 carbon from here. I'll remove this guy. I'll pick this guy away. I'll now draw 4 carbon now. 1, 2, 3, 4. Now, don't forget, I've removed 1 carbon. No? I've removed this carbon here. I've removed this guy. I've already removed this guy. So it remains 4 guys. See the 4 guys here. Now, that one that I remove, this is what I remove here. I remove CH3. Now, who can tell me where I can put this CH3? Don't forget, you cannot put it at the end, You cannot put it on the first. You cannot put it on the second. The reason is, you put it on these 2 sides, it will go back to this way. It will go back to how it was. If you're going to attach this one here now, it will go back to how it was. Yes, Gideon. I come on live every day. So it will go back to how it was. You cannot put this one at this place here. You can tell me where you can put it. You can put it down, yes, but it must not be on this carbon. It must not be, let me number it first. 1, 2, 3, 4. It must not be on 1 or 4. You can, thank you, either 2 or 3. It's either here or here you can put it. You cannot put it on that you remove now from here. You cannot put it on this last guy. You put it on this last guy, it will go back to the way it was. So you must put it on 2 or 3. So let me go and put it on 3 first. I want to put it on 3 now. Watch you. The bit is how it was. I'll put this on now. I'll attach it here. I'll blend it here. So see how it will now be. So you can see that this one is now a branch. This place is a branch. Or you can see if I go straight, this place will be a branch. So I'll just put all this hydrogen here. Or let me just ignore hydrogen. If you see this line like this, just know there's hydrogen because of time. Or should I put all the hydrogen? Let me just put all the hydrogen there. I think I'll be using blue pen to put the hydrogen because this marker is taking space. All right, see what I got now. Now we'll now name this one. Around 9 p.m. 9 p.m. Thank you. Okay, I'll be ignoring the hydrogen now. Yeah, let's name this one now. Let's get the longest chain. Longest chain is 4. Let me go straight. This is my main road. This is my road. This guy is not in my road. See my road here now. This is my road. I'm going straight like moto. So this guy is not in my road. So this guy is a branch. And this guy must be on a carbon atom that is small in number. That means you cannot attach this guy to a larger number. It must be on a small number. So since this is my road, I'll number it like this. 1, 2, 3, 4. This is my road here. Let me number it backward if you like, but it's not compulsory. So this guy is my branch. This branch is the carbon attached to carbon 2 or 3. We must give it small number. You cannot go and pick 3 methyl. 3 is too big. Pick 2. That means this is the correct direction. This is the correct direction. This is the correct direction here. So the name of this compound now is 2-methyl. What's the longest chain? 4. That's butane. That's one isomer. I've gotten one isomer like that. Don't forget that if you take this carbon atom and put it here, it's still the same thing. No, if I remove this guy now, I remove this one, and I put it on this same place, it's still 2-methyl butane. It will look like this now. It will look like this. Just that it will not be here. This is still 2-methyl butane. So no need. That means you are done with one carbon atom. You cannot put this carbon atom here or here. You can only put it here or here. And you can only put it on one side. If you put it here, it's 2-methyl butane. If you put it here, it's also 2-methyl butane too. As in, if you put it like this was how it was, 4 carbon atom. If you put it here, this is still 2-methyl butane. If you name it. If you put this one here, like this, it's still 2-methyl butane. So that means you are repeating yourself. So I think only one direction like that is okay. You cannot do the 2. So we are done with that one. Now let's go back and remove from here. Let's remove from here again. Now I'm going to remove 2 carbon from here. Don't forget that I've removed the first method. I removed 1 carbon. I arranged 4 carbon. It was 5 carbon. I removed 1 carbon. I arranged 4. And I found a place to attach the one that I removed. But now I'll remove 2. How many will now remain? 3. Abi? So I'll remove now. I'll now arrange 3. So these are the 3. I remove 2. I remove 1 CH3. I remove another CH3. Or let me just say I remove something like this. This is what I removed. So now these 2 guys that I removed, these 2 guys cannot be at this 2 ending, no. Because if I put them at the 2 ending, it will go back to how it was. They're gonna last time I removed. You can see what I removed here. I removed this one and I removed this one. I cannot put the 2 of them back at the middle. Sorry, at the ending. It will go back to the longest chain. You understand? It will go back to how it was. So I need to put it in another place. So I will put these 2 guys on this middle guy. If I put one here like this, one here, and put on that one here, this is still pentane. This is the normal pentane. See, this is 1, 2, 3, straight chain. So this is still normal pentane. So that means it cannot be like this. It has to be in the middle. Like one will be up here, and that one will be down here. Like this. This is how it has to be. Like two of them will attach to the same carbon. We are doing organic chemistry. So this one will be CH3. This one will be CH3. So you can now name this one now. Thank you. 2,2-dimethylpropane. Nice one, guys. So the name is 2,2-dimethylpropane. So, do you understand? Any question? Do you have a question? Any question? Okay, no question, Abi. All right. So that's the structure. So pentane now has 3 structural isomers. Pentane, it has 3 structural isomers. So this is the first one here, normal pentane, that is N-pentane. Second structure is 2-methylbutane. 2-methylbutane, and the last one, 2,2-dimethylbutane. That means pentane has 3 isomers rather. Pentane has 3 isomers. 3 isomers. First one, normal pentane. Second one, 2-methylbutane. Last one, 2,2-dimethylpropane. Any question? Is there any question? Ask. Okay, so he said how many isomers does butane has? Butane has 2. Butane has 2. See the 2 here. We did it just not long ago. Butane has 2 isomers. The first one is 2-methylbutane and the normal butane. Normal butane, you can call it N-butane. Isomers of butane, you have N-butane. That N means normal butane or N-butane. Then the second isomer of butane is 2-methylpropane. Okay, so I hope you are okay with that one. Now let's move on to functional groups so you can understand it better. Do you understand? Now for functional groups, pay attention. You learn how to name very well now. Your naming this will improve very well now. So let's go to methyl groups. Some of you that are having issue with methyl, please subscribe to my channel and like the live. Let's go, like the live. So methyl group, the general formula of methyl group is CnH2n plus 1. Okay, CnH2n plus 1. That means that if you have your methane, for example, this is methane now. If you have your methane, go to your methane and remove one hydrogen. What will you get? You will get CH3. This CH3 is called methyl. The general family of this guy is called, they are called alkyl groups. That means just go to your normal alkane family, remove one hydrogen from there. For example, if you go to ethane now, go to your ethane. Ethane is C2H6. Remove one hydrogen from there. That will be C2H5. This one will be called ethyl. Then you go to C3H8. I remove one hydrogen. That will be, this is propane. If I remove one hydrogen from here, that will be C3H7. Who can tell me the name? C3H7. What is it called? Try C3H7. C3H7. What is it called? Fast, so we can move on to functional group. Propyl. Okay, that's correct. Propyl. Now, for functional groups, functional group is just a group of atoms or a radical that helps you to determine the property of that particular organic compound. So it is an atom or a radical, or a bond common to every homologous series, and that bond determines the chemical properties of that series. Take for example, let me do OH for example. This OH is the functional group of alcohols. Every alcohol has OH in its formula. The functional group of alcohols is ROH. So any organic formula that has OH in it is an alcohol, or you can say it's an alkanol or alcohol. So all of them have ROH. For example, this RO now can be C2H5OH. This one here is called ethanol. Ethanol is ogogoro. The one you drink in action bitter, shekpe, you understand? Where you go high. This is what they use in brewing industry. They use it in brewing industry to make trophy and all those hot drinks. Now, these alkanols, they always have OH in their formula, and their general molecular formula for alkanols, their general molecular formula is CnH2n plus 1. They now write OH at the back. CnH2n plus 1, then put OH. What if n is 2? That's how I got this formula. When n is 2, I came to put 2 here. So if n is 2, put 2 here. That will be C2. Then n is 2 now. 2 times 2, 4. 4 plus 1, 5. C2H5, then OH. You understand? Some textbook can write it like this. Sometimes JAMB write like this. C2. They'll combine all the hydrogen together. That will be C2H 5 plus 1 6 now. C2H6O. Please don't confuse it. This is also ethanol. You understand? This is also ethanol. This is also ethanol. But most of the time, it's always written as C2H5OH. Now let's look at another family. These guys here, they call them alkanols. They always have ROH in their formula. You see OH in their formula. Now, how do you draw the structure? Let me teach you the structure. See the structure here. C2H5OH. This is oxygen. Oxygen must have 2 lines around it, like in organic chemistry. You must have 2 lines joining oxygen. You cannot draw only 1 line to oxygen. So I need 2 carbon. Let's go. 1, 2. Then each carbon, we have 4 lines coming out of it. 1, 2, 3. So 4. 1, 2, 3. Like that. Now I will attach hydrogen here. So hydrogen here, hydrogen here, hydrogen here. This is 3. Another hydrogen here, another hydrogen here. How many now? 5, Abi. 1, 2, 3, 4, 5. That means that this O and this H, they are together. So you just put them together like this. Or if you like, break the bond here. Break this guy here. That will be C, C. Break it at this point. Instead of writing OH, instead of writing H, write O, then put dash, then put H. It does not matter. It's still the same thing. So this is ethanol, structure of ethanol. Hope you understand. Hope you understand. So they have OH in their formula. They call them alkanols. Let's go to another family. This one they call them carboxylic acid. They also call them alkanoic acid. Alkanoic acids. Take note of alkanoic acids. These alkanoic acids, their functional group, so that you can identify them when you see it. When you see that functional group is RCOOH. They have COOH in their group, in their formula. You must have see this COH in their formula, sir. This COH, you must see it in their formula. So this is the functional group that helps you to identify them. They are organic acid. These are organic acids. They are actually weak acids. So they are weak acids, not that strong like all this HCl, H2SO4, and so on. So this arrow here, you know the formula of arrow now. Arrow is CN H2N plus 1 COOH. This is the general molecular formula of alkanoic acids. So alkanoic acids, they have COH in their formula. Example is CH3COOH. Please subscribe to my channel. Thank you. So this CH3COOH is called ethanoic acid. So you must just see this COH in the formula. So how do you draw this one? You want to draw the structure now. You want to draw the structure. How we draw the structure? See how to draw it. This C, this one that C, Abi. Take notes. Now there's something called a carbonyl group. Carbonyl is C and double bond to oxygen. It is present in this COH. That means one of these O is attached with double bond to the oxygen, to the carbon like this. Then this one will take your normal hydrogen. Then this second line here, don't forget that each carbon must have 4 lines. See now, 1, 2, 3, 4. This second line rather, you now have O and H together. Then this is now your normal CH3. So this is CH3COOH. This is how to draw it. CH3. This one is single bond though, but there's a double bond attached to this oxygen here. CH3COOH. You understand? So that's how you identify organic acids. Okay, I hope you understand. Let's do the next one. The next one, these ones, they call those ones esters. They call them esters. So these esters, they have fruity smell. That means they should smell nice. They use them in making perfume. All these perfumes you are spraying, all of them, they contain esters. There are even some esters that have banana smell, a compound, but it has the smell of banana. They call it banana flavor. It's an ester. And these esters, you can also call them alkanoids. So when you see alkanoids, it means esters. Esters and alkanoids are the same thing. Please don't like the live. Like the live. So esters and alkanoids, they mean the same thing. So these esters, their formula is RCOOR. So this is the formula for esters here. RCOOR. So how do you draw it? You draw C first. Carbonic group is here. Don't forget what I told you. Carbonic group C double bond O is here. So one of these C here will be bonded to oxygen. Then here will be bonded to one of the O. Then you now have R. Then the other R will now be here. Don't worry, I'm getting to benzene. I'll do benzene after this one. Don't worry, I'll do benzene after this one. So you have CH3, COOH. I'll do benzene after this one. So CH3, COOH. This is, sorry, I made a mistake. Example is CH3, COOC2, H5. So this is ethyl. So you call the back first, ethyl ethanoate. So I hope you understand this one, ethyl ethanoate. So let's go to benzene then. Since you guys want me to explain benzene. So benzene are aromatic compounds, but before you can do benzene, you first of all know the structure. So let me just give you the structure of benzene first. So benzene is an aromatic compound. Take note of that. So when you talk of benzene, the structure of benzene is like benzene is hexagon. Should we know how to draw hexagon now? This structure of benzene here. Let me like the live, share the live with your friends. And if you are new here, subscribe. This is how I draw benzene. So just draw hexagon like this, then draw circle inside. Or if you don't like this method, if you don't like this one, draw another hexagon. Then put double bond on one of them. Don't put here. Since you have put here, skip this one. Go to the next one, put here. Skip this one, then put here. This is benzene. Anyone you like. This is the benzene structure. And this benzene is a liquid. It's not a gas. So benzene is a liquid. It's a liquid. It's used as a solvent, actually. So it's a liquid and it is aromatic. The class of benzene, like the class of compounds it belongs to, they call them aromatic compounds. Aromatic. That means they have a sharp smell. Should we know this akpari now? Baba akpari. This drink that they call Baba akpari. That name, aromatic, it's just like that. So benzene and benzene-like compounds are actually called aromatic compounds. Yes, I will explain it. Hold on, don't worry, I will explain it. They're actually called aromatic compounds. Okay, hold on, I'm going to explain pi and sigma for you. Yeah. So, any question on that? Since there's no question, let me just give you some properties of benzene. Then I'll move to the pi and sigma bonds. Then, when I say pi and sigma bonds, then I'll go to another aspect. So let's look at the properties of benzene so you can understand benzene very well. So let me draw the structure once more for those of you. So any compound that behaves like benzene or acts like benzene or has structure of benzene in its formula, that compound we call aromatic. So you call it aromatic. And let's look at when one of this stuff is. Let's look at the properties of benzene first. Let me finish benzene. Benzene is very short. Let me finish it first. I'll go to the bonds. Just calm down. Benzene is very short. It's very short. Benzene is not much. From the syllabus, benzene is very short. Within 15 minutes, we'll finish benzene. So let's look at benzene now. So there's a guy. The JAMB normally asks the name of that guy. His name is August. Kekule. August Kekule is the one that came up with the structure of benzene. He studied the structure of benzene and came up with this structure. This structure is called the resonance structure because the electrons in benzene, they can move around, like the double bonds interchanges. They do not belong to a particular carbon atom, so they can change. For example, if I put on double bond here, I'll skip this one, put here and put here. Later, this thing can also switch like this. Can also switch like here, come here and come here. So you can say it's interchanging. At this point it was here, but now it came here. Later it came, it's interchanging, it's going around. So because it's going around, they came up with this structure. This one is called resonance structure. So instead of drawing these two and be confusing yourself, you can just draw this one to represent benzene. I hope you understand. So this one here is the intermediate of, like when you combine these two together, you will get this one. That is called the resonance structure. Now let's look at physical properties of benzene. Physical properties of benzene. Resonance structure. Resonance structure. This is resonance structure of benzene. So it's a hexagon with a circle inside. Now, physical properties of benzene. Let me ask a question. Is benzene a liquid, solid, or gas? Who want to try this question? Is benzene a liquid, solid, or gas? Is benzene a liquid, solid, or gas? All right, liquid, number one. It is a colorless liquid. So benzene is a colorless liquid. It's colorless. It doesn't have any particular color. And two, it is insoluble in water. It is insoluble in water. Thank you. It's a non-polar liquid. It is non-polar. Okay. Then boiling point. Benzene has a boiling point of 80 degrees C. So the first one is that benzene is a colorless liquid. Okay, it's an organic liquid. So you can say it is non-polar. It does not form ions. And it is a non-polar liquid. It is insoluble in water. Benzene cannot dissolve in water. And it has a boiling point of what? 80 degrees C. A bit close to the boiling point of water, but it's a bit far small. These are the physical properties of benzene. Hope you understand that one. Now let's look at how you replace the carbon atoms in benzene. So let's see what happens when we remove one carbon atom. Like this stuff like this now. If I write OH here, like what would the name be? Like what will you call this compound with OH here? Before you can understand what this compound can be called, you have to understand when nothing is there. Imagine when I draw the structure, but I didn't write anything here. Like this structure like this now. Like this. I just put circle here. I just put a line here, and I didn't write anything here. This guy here, the way it is like this, is called phenyl. This is a phenyl. Sorry, I didn't spell it well, sorry. It is phenyl. It is PHENYL. Just like methyl and methane. You know, methane is CH4, but methyl is CH3. The same thing. In terms of benzene, if you remove one of the carbon atoms there and put a branch there, it will be phenyl. So this phenyl now, and I put OH there. OH, the name will now be phenol. So this one now is phenol. Yes, benzene and water can undergo, no, fractional distillation is if the temperature are close. You can still use simple distillation for it. Take for example, the temperature change, benzene, water is 100 degrees C, benzene is 80 degrees C. Temperature change is 20 degrees C. Temperature change, delta T. Temperature change is 20 degrees C. That means it's a bit higher. So if you want to separate the two of them, and you want it to be very extremely accurate, you have to use what is called simple distillation. Simple distillation is for 20 degree and above. 20 degree and above. Temperature change 20 degree and above. Once it's at 20 degree, once temperature change is less than 20, you have to use fractional. Fractional is more accurate. Fractional distillation is more accurate than simple distillation. Fractional, if the temperature change between them is like 10 degrees C, 5 degrees C, that means that boiling points are near, then fractional distillation will be proper. But if the boiling point is far from each other, like maybe 20 and above, 25 degrees and above, you have to use simple distillation. I hope you understand. Now, this is now phenol. But what if I remove this OH and put CH3 there? What will it be? So I'll just put CH3 here now. So I'll put my normal benzene. So this one now, the name is called toluene. It's also a liquid too. Toluene. This is toluene. Now this toluene can also be called another name. You can call it methylbenzene. Methylbenzene. Toluene can also be called methylbenzene. Hope you understand. Methylbenzene. Then there's also another one, the last one we're going to look at. I'm going to put two CH3 groups. I'll put one CH3 here. I'll put on that one at this side. So this one now, you can call it the long way. Number it 1, 2, 3, 4, 5, 6. So this one will be 1, 2, 3. Don't count this two. That will be 1, 3. So you can call it 1, 3 dimethylbenzene. So this is 1, 3 dimethyl. That's on that name, silane. Washiri, nice one. Biobaku, nice one. Silane. Which part don't you understand? Drag edits. Mention the part you don't understand. Like when you don't understand something, just tell me the parts that you don't understand. Don't say I don't understand. Mention the parts so that I can be specific when I'm trying to teach you. You understand? Just mention the parts that you don't understand. Like be specific, like this particular place, this particular part. These edges, they are carbon atoms actually. This carbon that is there. As in, see the full diagram here. This is what it looks like. The full diagram is like this. Put one C here. Put one C here. This is what it looks like. Then each of these lines are now hydrogen. Each carbon has 2 hydrogen attached to it. Like this is what it looks like. This is benzene here. But instead of drawing it like this, you can draw it with the normal way. This way here. This one is better. Let's go to the next one. Please take note, the kind of reaction benzene undergoes is substitution reaction. Benzene undergoes substitution reaction. So it has double bonds, but it undergoes substitution reaction. Okay, let's look at the first one. The first reaction of benzene from the JAMB syllabus is the reaction of benzene. Formation of chlorobenzene. So benzene plus chlorine. Benzene plus chlorine. What will happen when you react benzene and chlorine together? So from the JAMB syllabus, no. It's not saturated. It's unsaturated. I didn't put the double bond. I didn't draw the double bond though. It has double bond. I didn't draw it. It's not unsaturated though. So when you add benzene plus chlorine, what will you get? From the JAMB syllabus, they say you should check for the reaction between benzene and chlorine. So reaction between benzene and chlorine is a substitution reaction, and that reaction will give you a compound called chlorobenzene. The product is chlorobenzene. That's the product, chlorobenzene. Do you understand? Chlorobenzene. So let's look at the reaction here. So the formula of benzene can also be written as C6H6. Don't forget, benzene is C6H6, the molecular formula. Benzene is C6H6. So I'm doing C6H6 plus chlorine. Chlorine is Cl2. So that will give you one of this chlorine will replace, like this chlorine will kick off one hydrogen from here. So it's going to be C6H5. One H has gone off, so chlorine will replace it. That will now be Cl. So you can see everything there is 6. 5 plus 1 is 6. So one hydrogen has gone off. So that hydrogen that has escaped, that hydrogen will now escaped, will now react with the chlorine that came here. So one chlorine came here. It will remain only one chlorine from here. So the hydrogen that this chlorine chased away from here will now react to the chlorine that was left here. So you're going to get a product, HCl gas. This HCl gas is called hydrogen chloride gas. So this is the product here. This guy is called chlorobenzene. If you draw it, it look like this. Just put Cl here. This is chlorobenzene. 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 What if I put F here? What will you call this compound? What will you call this compound? What will you call this one? Just F here. F, what will you call it? All right, that's fluorobenzene. Fluorobenzene, that's very, very correct. Nice one. So benzene also undergoes addition reactions. Okay, so let's look at reaction of benzene, hydrogenation of benzene. So in this reaction of benzene, this one JAMB have asked it plenty times. This reaction of benzene, JAMB down some plenty times. So this one, you take benzene, C6H6, you combine it with hydrogen. This one is the catalyst. The catalyst used is nickel catalyst, nickel catalyst. So you will get a product called cyclohexane. Cyclohexane, that's what you will get. So let me just show off cyclohexane for you. The temperature must be 180 degrees C, 180 degrees C. So benzene reacts with hydrogen under the action of a nickel catalyst at 180 degrees C to give you what is called cyclohexane. Cyclohexane is the product formed. So cyclohexane looks like this. It looks like benzene, just like benzene, but it does not have any double bond. So cyclohexane is like this. So here will be C, 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 C. So it does not have any double bond. So this one will take 2 lines. This one will take 2 lines, 2 lines, 2 lines. Each of these lines hydrogen. So this is a compound called cyclohexane. Let me redraw it again in case you don't understand. Like draw one line here, put carbon, put carbon, put carbon, put carbon, put carbon, put carbon. Each of these lines, you now put hydrogen to it. No double bond here, because hydrogen has replaced it. Hydrogen has kicked off all double bonds. So the double bonds are now straight chains. So we call this cyclohexane. This is cyclohexane. So hydrogenation of benzene under a nickel catalyst at 180 degrees C will give you cyclohexane. The last one is use of benzene. What can benzene be used for? Use of benzene. What are the uses of benzene? So you have one. Don't forget that benzene is a liquid. Benzene is a liquid. So benzene can be used to make toluene. And this toluene is used in making explosives. They used to make bombs. Hope you understand. So you can use benzene to make toluene. Don't forget that toluene is methyl benzene. That is your normal benzene ring. Then now put CH3 there. And that's methyl benzene. Then
It can be used to make bombs. Then the next one, it can also be used to make nylon. You can use benzene to make nylon. And take note of something. This nylon, the polymer, benzene, you must first of all convert the benzene to what is called styrene. Yes, because of synthetic materials, yes. Do you know what styrene? Let me tell you what styrene. Do you know this styrene is, let me give you one example. Do you know this fuke? This takeaway pack. There's one takeaway pack that is like paper. It's not paper. I wish I can snap it. I don't have anyone here with me. But if you put food inside it, it used to tear. It's like fuke. Or that stuff that if you buy new radio or new television, that white foam that you will see that they used to wrap the freezer or they used to wrap television, that white thing, they call it fuke in Yoruba. They even used to make gum. Some children will pour petrol. They will pour petrol on top of it. It's not turn to gum. That white thing is what is called styrene. Cork. Some people call it cork. That's what it's called. The new name is styrene. They use this in that takeaway. One new takeaway that if you put hot rice or hot food inside it, it will tear. That one is like it's cheaper than the normal takeaway. Yes, this is to make gum. If you pour petrol inside it, you turn to gum. So that stuff is styrene. So before you can use benzene to make nylon, we first of all convert that benzene to styrene. So when that benzene is converted to styrene, you can now use to make nylon. You understand? And benzene can be used to make phenol. And chemicals like this aniline. That aniline can be used to make aniline. And all these ones are used in making dyes. They use them to making dyes and chemicals. They also use to make pesticides because an insecticide. It's inside insecticide to kill insects. Then this one, aniline. This aniline is used to make drugs. It's a derivative of benzene used to make drugs. Naphthalene is benzene family too, is benzene family. The structure is, let me just structure. You have two benzene, like when you carry two benzene ring and you join them together, like you carry benzene plus benzene, you now put the structure together. You understand? Like something like this. This is benzene here. You now put another one at the side so that it blends together. Are you following me? You put on that one by the side here so that it will now blend together with it. Like this. You put on that one by the side, like this. This is naphthalene. So naphthalene is just two benzene gummed together. You understand? Okay, yes, take away. That takeaway is pack. So now let me quickly explain. Any question? That's the end of benzene. Subscribe. Subscribe and like the live. Let me see the last thing. So let me see the last part. Sigma and pi bond. Like someone said, you should treat sigma and pi bond. So, oh yeah, take us back. What's the question?
Okay, substitution reaction. Yes, it can be used to make detergent. It can be used to make detergent. There is a benzene derivative that's used for making detergent. Yes, it's used to make detergent too. Substitution reaction. Let me explain it easily with methane for you. Methane plus chlorine. Watch you. Methane is CH4 plus chlorine under the presence of sunlight. This reaction is the easiest way to understand substitution reaction. This is the easiest way. So what is going to happen is this is benzene here. Sorry, methane abi. It has 4 hydrogen. You're now reacting it with chlorine. What's going to happen is that the chlorine will be replacing 1 hydrogen from here. As in, chlorine will kick off 1 hydrogen, 1 1 until hydrogen is no longer here again. The first way to be like this: C, abi, C, H, Cl, H, H. This is the first way to be. In this first case here, the chlorine has kicked off 1 hydrogen. So this one here is called chloromethane. Second case, chlorine will kick off another hydrogen again. So it will be 2 chlorine there now. There will be 2 chlorine there. Chlorine is just replacing it. It's just replacing the hydrogen. This one now will be, since it's 2 of them, call it dichloromethane. Then later, it will now be 3 chlorine now. Who can tell me the name of this one? What's the name of this one? 3 chlorine like this. What's the name? What's the name of this one? So this one will be called trichloromethane. And the last one, kick off this last guy. So hydrogen will not be there again. So this one is Cl. Hydrogen is no longer there. So what will you get? Tetrachloromethane. So that's how to understand substitution reaction. Very easy. It takes place in presence of sunlight. Any question? Any question? Which one? Which part? This reaction is just be changing it. Just be changing the carbon atoms. Be changing the hydrogen and be replacing it with chlorine. Okay, so let me go to the sigma and pi bond. Someone said sigma bond. So the bond in a single bond contains 1 sigma bond. When you see 2 double bond, like double bond 2. I don't understand your question. Please be specific so I can know the exact thing you're talking about. So 2 double bond like this, if it's 2 like this, it contains 1 sigma bond. Sigma is this symbol here. Then 1 pi bond. Then if it's triple bond like this, it also contains 1 sigma bond and 2 pi bond. You'll be changing it. It will be changing. See, chlorine is not 2. It's changing. The reaction is changing. See, the first way, chlorine is 2 atoms here. One of the chlorine will chase hydrogen from here. 1 chlorine from here will change this hydrogen. It will not be like this. Another chlorine again will change another one. It will not be 2 of it, then 3 of it, then 4 of it like this until nothing is there. So that the chlorine is chasing the hydrogen away. That's how it is. That's how to understand substitution reaction. Remove the hydrogen and put chlorine there. You understand? Remove the hydrogen and put chlorine there. Like that. Be replacing the hydrogen until no hydrogen will be there again. That will not be tetrachloromethane. The final product formed is tetrachloromethane. So let's look at how to check this stuff. So they might ask you, I think they've asked that question before, like how many double bonds. So let me ask you this question, or let me do this one, then I'll give you one to try. Then you can end it there. So the question is, how many double bonds, how many pi bonds? Let me write the questions here. It's a JAMB question. Oh. How many pi bonds how many pi bonds how many pi bonds how many pi bonds are in an alkene with 6 carbon atoms? See the question here. How many pi bonds are in an alkene with 6 carbon atoms? So if you watch carefully, an alkene, the options are A1, B, 6, C, 5, D, 3. How many pi bonds are in an alkene with 6 carbon atoms? So let's check. An alkene that has 6 carbon atoms, okay, is hexene. So we have alkene. Formula of alkene is CnH2n. So since it says 6 carbon atom, that means N is 6. That will be C6H12. So this is an alkene here. So it has 6 carbon atoms. If you draw the structure, it will look like this. It has double bond on one side because it's an alkene. So 6 of it like this. 1, 2, 3, 4, 5, 6. So how many pi bond will be there? Don't forget that pi bond can only exist where there's double bond. Don't forget that. See the breakdown I gave to you. Okay, I've removed it. Single bond contains 1 sigma. Double bond contains 1 pi, 1 sigma. Triple bond contains 2 pi, 2 pi, 1 sigma. Hope you understand. So since they said double bond, only one double bond is there. So it will be on one side. So that means it will have only 1 pi bond. It will have only 1 pi bond. So the answer is option A. Do you understand? Do you understand? So thank you for supporting me. So let's stop here. We'll continue tomorrow. So let's stop at this point. So we'll continue tomorrow. So make sure you like the live, and if you want to join my online class, my revision class is 070-388-45741. So the revision class is very affordable, just 1,000 naira to join the revision class. I teach there every day, physics, chemistry, all your normal subjects. So it's 1,000 naira to join that class from now till any day you write your JAMB examination to the end of April. So if you're interested in joining that class, just message me. I'm going to add you on my WhatsApp. So Ugochi, my battery is low. I understand you. Ugochi, thank you. I really understand. My battery is low, that's why. My phone was not off. So I'll see you guys tomorrow. Tomorrow is Friday. So let's make it 9 o'clock. Don't worry, I'll refresh your memory. We'll do chemical bonding tomorrow. JAMB like this topic, chemical bonding. So I'll treat it tomorrow. So hope you have gained something. Please make sure you leave a good comment and subscribe to my channel, and make sure you click subscribe if you are new here and support me. Thank you. I'll be making more videos for you guys. So you can just post the topic you don't understand so I can do a revision of it. So thank you so much. I really love you guys. I really appreciate you. So thank you guys. I'll see you guys tomorrow. Okay. So see my number here in case you want to contact me. So take care of yourself and be prayerful. Be prayerful and relax and have a good sleep. My prayer that all of you do in Jesus' name. This year is your year of admission in Jesus' name. This year is your year of admission, year of good news in your WAEC, in your NECO, your WAEC, your JAMB. Positive things happen to you in Jesus' name. So stay positive and we'll see you tomorrow. Okay, 9 o'clock or let's say 9:15 p.m. tomorrow. Okay, all right. Take care, guys. Take care. I love you guys. Take care, everybody. Bye bye. Bye bye, everybody. Take care. Thank you for supporting me. God bless you.